Okay guys, the word of the day today is non-disjunction. I'll write it down in a minute, but I just want you to look at the picture up here for now. It's easy. It's actually easy, but you have to remember the process of meiosis. Okay, remember, meiosis is that process that makes gametes, whether they're eggs or sperm. Okay? Well, meiosis can go wrong. Problems can happen. And that is called non-disjunction, when a problem happens in meiosis. According to this picture, you have two cells, okay, and they're going to take both of these cells through meiosis. The one on the right's doing it right. That's how it's supposed to look. That's how meiosis 1 is supposed to look. That's how the chromosomes during anaphase 1 of meiosis 1 are supposed to separate from each other. However, on the left, you can see there's a problem. There's a problem. They don't separate the right way. So what non-disjunction is when the chromosomes fail to separate the way that they should. And if you could kind of fast forward this picture on the left, you'll see that the chromosomes are going to get divided up, not the right way. One cell's going to get too many, one cell's going to get too few. You're going to make eggs and sperm that are not correct, that are not right. Okay, so non-disjunction will lead to certain disorders and certain chromosomal disorders. The only thing this picture is going to show you, I'm going to keep going here, it's going to kind of keep adding on pictures. Non-disjunction can occur during meiosis 1, or it can occur during meiosis 2, and that's what the next picture shows. Now it looks a little busy, but this is the only thing that I wanted to show you. This cell over here on the right started off okay, but you can see once it got to the second phase of meiosis, that's where non-disjunction took place in that cell. Okay, remember in meiosis 2, they were supposed to line up again. Remember, the whole process kind of repeats itself. The chromosomes line up again in single file. Well, they did that correctly, but they're not pulling away right. Again. So here, what's the point? The whole point is, let's go to the end. Fast forward to the end. Here are all your gametes that you're going to be making. And you can see there were lots of screw-ups up here. And it's showing you that, okay, and you should be able to look at that top picture up there and tell if there's 4 chromosomes to start off with. Over there, same thing. There are 4 chromosomes to start off with. And remember, meiosis is supposed to, in a perfect world, take a cell with a certain number of chromosomes and cut it in half. Well, ideally, you should have 2 chromosomes per cell. You don't have that down here. You got 3 here, you got 3 here, you got 1 here, 1 here, and all these are not right. And remember, these are going to be like sperm or eggs. If those go on to hook up with another gamete and form an individual, that individual isn't going to turn out quite right. Okay. Same thing over here on this side. Non-disjunction happened a little later, but still, same deal. You basically have just a little, it's just not quite right. Okay, now you see some of them turned out okay, luckily, but not all. And it's kind of a matter of, well, it's like luck, it's like rolling the dice. You know, every man and woman are going to make eggs and sperm that screw up every once in a while. That's just, it has nothing to do with being sick, nothing to do with whatever. Yeah, when you age, as you age a little more, this happens a little more. But that's the same in both man and woman. You know, you get a little more of this going on. But to be honest, this happens all the time anyway. And if that egg hooked up with that sperm and one of them had a problem, it's going to lead to something. Oops, that's not you guys. So anyway, oh well, and you guys, I might as well show this. Hopefully you can see that if the chromosomes don't separate right and you make the wrong eggs and sperm, you're going to end up with, with disorders. And this is when you guys did your karyotypes. You should be real comfortable with looking at one of these. This is a karyotype of somebody with Down syndrome. You can see how there's 3 chromosomes at the 21 location. And a lot of people say, well, how do those 3 chromosomes get there? Well, that's the picture you just saw. You had non-disjunction, which basically was that process where the chromosomes didn't separate right, and that's what's going to lead to this kind of deal. Okay, Down syndrome's mild. I mean, this is Down syndrome. People with Down syndrome lead very normal lives. I think I remember, some of the other disorders that we saw pictures of the other day were not so innocent and nice. So, all right. So the only thing I want to do today, this isn't going to take long. I want to finish up a couple of things. I want you to write down the word non-disjunction. And write down the definition. Non-disjunction is when the chromosomes fail to separate correctly. And I put the word meiosis in parentheses because that's where it happens. It's basically meiosis gone wrong. And as a result, you will produce gametes with the wrong number of chromosomes. Either too few or too many. I wrote down a few of the disorders, and I grouped them. You have trisomy 21, trisomy 13, trisomy 18. Those are the ones that were on your guys' karyotypes that you did the other day. And I labeled those collectively as autosomal disorders. A-U-T-O-S-O-M-A-L. It's kind of squished there. Autosomal disorders. But you should recognize that word autosome. Remember, most of the chromosomes humans have are autosomes. It's basically the first 44 chromosomes we have. They're the tallest ones, kind of. Well, I guess I can't really say that, but they're the first 44 chromosomes we have. All the genes for things not related to your sex are there. Doesn't determine whether you're male or female. Now, when non-disjunction occurs in your autosomes, you get disorders like that. When non-disjunction occurs in your sex chromosomes, then you get other disorders like Klinefelter syndrome and Turner syndrome, and there's a bunch more. So I wanted just to remind you the difference between autosomes and sex chromosomes and give you this word non-disjunction. None of this is really new. We're just kind of expanding on things a little more. The next thing I want to talk about is some tests that you can get done at a doctor to determine whether or not non-disjunction has occurred. I'll wait a minute here, though, for everybody to catch up. Everybody ready? There are a couple tests I want you just to be familiar with. To be honest, I more want you to be familiar with these because maybe one day you'll have to have one. Well, ladies, I guess. If you ever get pregnant, there are a couple of tests that can be done, and not every pregnant woman has these done. These are kind of reserved for people who are at risk. Amniocentesis. Okay, amniocentesis is a process, and then there's another one called chorionic villus sampling. Yeah, that was one that's not as heard of as much. You might have heard of amniocentesis. Both of them do the same thing. Both of them take a sample of fetal cells and make a karyotype of them. So you can do either one of these techniques. You get some cells of the baby, and you can take those cells and turn them into a karyotype and figure out if there's a problem or not. The difference between these two tests is that amniocentesis, they actually take what's called amniotic fluid. In other words, the fluid that surrounds the baby in the womb is filled with the baby's cells. Okay, so they actually take the fluid that surrounds the baby and they test that. The other technique actually takes a tissue sample, so it's not taking fluid, it's actually taking a tissue sample from the placenta. You guys know what a placenta is? Yeah. Okay. A placenta is, think of it like a placenta as like a go-between between mommy and baby. So it's almost like a storage tank in a way. When mom eats, mom stores nutrients in the placenta. Those nutrients will eventually be given to the baby. Baby makes waste. Those waste sent to the placenta for mom to get rid of. It's like the go-between between mommy and baby, this placenta. So it's filled with the baby cells. Okay, so that's kind of why they can take a sample of that as well. The placenta, it's interesting when if you ever had the chance to see a birth or have a birth or whatever, the placenta is it kind of comes out a couple minutes after the baby comes out. It's like a whole separate organ. It's bigger than you think too. It's like that big. It's big. It's like this purple bag looking thing. It's not bloody or anything. It doesn't look gross. It's just like this purple bag thing. It's funny. You never think about these things. I don't know. I was dumb and didn't realize it just kind of popped out a couple minutes after baby does.
You don't even have to deliver it. It just like kind of falls out.
It just kind of pops out after the baby. It's not as big as the baby, so you probably don't even know it's there. It's the reason I bring this up, not to gross you out.
I'm never having a kid.
Yes, we did.
Did you really in health class?
Let's
not go down there.
This is the human body.
Let's not go down there.
Okay, hold on. I can't hear this though. But
You probably don't want it.
no, it's all because I want to tell you a story about a placenta. You talk about it in health class.
This isn't about the placenta. It's not about what we're talking about today, but it's still gross.
Okay. No, well, just here the word. The only thing I was going to bring up is you want your placenta to be healthy and happy, and you want it to be kind of healthy. In people who smoke, in women who smoke, being pregnant, that placenta will come out tar black.
That's nasty.
Yes. So my point is, what do you think? Don't smoke.
Never. Not even when you're pregnant.
Not even when you're pregnant. And if you know what, you guys are early enough. Don't even smoke now. It is worse to smoke than just about anything else.
Can it still come out like that from secondhand smoke?
Yes. But I mean, if you're around it all the time, yes.
How does
Yes.
alcohol?
They can judge doctors. I'm sorry. I'll answer your question in just a minute. Your doctor will definitely be able to tell what exposure you've had to alcohol, drugs, smoking, pretty much by the shape of your placenta that comes out, and they'll know. They'll know. Yeah. You said, what was your question about alcohol?
About the alcohol. Because babies come out with disorders like
Yes.
drink.
There's like a fetal alcohol syndrome. You know what? When we will talk about that in the future. I know I want to kind of stay on track, but it's very much something you guys will want to hear. So hang tight on that one. Yeah.
There's this girl who goes to my church, and she had to have like surgery yesterday because her mom was a drug addict. Well, she still is, but was a drug addict all through when she was pregnant with her.
Yeah.
So they didn't expect her to live like over the age of like 12 or 13 or something.
Yeah.
And she's doing like really bad. She can't even walk.
I
or
would not
anything.
stop.
And she's like really, really tiny and short. She's like 4 years older than me, and I tower over her.
Yeah. It's very. I don't know if you guys realize it. It's when you're what'd you say?
Well, I tower over Shane, but he's older than me.
They're just picking on
I
you
tell
this
her
week.
Lee and she goes right.
You gotta understand when you guys are developing, when a baby is developing
it's
in
like
the
looking at
womb,
the ground.
cells. Remember, listen, they're still stem cells. We've heard that word, stem cells. They're not. Those cells don't have a job yet. If those cells are being exposed to drugs and alcohol, smoke, they're not going to form right, and they're most definitely not going to form into the cells that they're supposed to be. There's going to be problems. So that's kind of my general answer for that. You know, it's difficult enough creating a normal human life. But yeah, I've seen. I've been lucky. I haven't been exposed to people. I think the worst case scenario, I see every once in a while some pregnant woman like smoking, and I just want to run up to them and like slap them. But it's also, I realize that it's a very hard habit to break. So
Smoking?
yeah, don't start smoking, people. And if you are, stop. I can't. It is better to be extremely obese than it is to smoke as far as from a health standpoint.
I would
Smoking is
say
one of
something,
the
but it's really
worst
mean.
things you can do. What?
I said I would say something, but it's really mean. I'd probably get in trouble.
Don't say it then.
I'll tell you after class. I don't say it in front of everyone.
Won't say it on camera.
Which is better, chewing or smoking? Because I got my dad quit smoking, and then like 2 days after he started chewing, so
They're both not good.
he's not quite chewing as a father.
Now my dad
I'll just, guys, this is, both of them have chemicals that are going to go right to your cells and mutate your DNA. You don't want mutated DNA.
I'll try to eat. Stop.
Okay.
That's gross.
Finally, kind of a separate topic, something called the Human Genome Project. This was probably, and still is, one of the biggest science projects they had going on in recent time. It was started in 1990, it ended in 2003. In other words, it was a 13-year project. And the whole goal of it was to sequence human DNA. Basically to take human DNA and figure out where all the genes are located. I realize there's some words on here you don't know yet. These will make more sense next chapter. The goal of this project was to sequence the 3 billion base pairs, and I realize we haven't heard that word yet, of human DNA. I drew a picture over here of a ladder. That's what DNA looks like. We're going to talk more about that next chapter. A base pair, you can think of a base pair as like a step of the ladder. So a piece of human DNA has 3 billion steps to it. It's really big. It's a really big piece of DNA. Each of those steps has a code. And together, with lots of those steps, make up a code to make some protein. Well, lots of those steps make up a gene. The genes, as a result of this project, here's my point, they were basically able to locate where genes are located. In other words, after this project, they knew where the gene for cystic fibrosis was in human DNA. They knew where the gene for Tay-Sachs was. They knew where the gene for cancer was. They were able to figure all this out. It was a wonderful project. However, there was some ethical issues raised. As a result, this thing ended in 2003, and then it got everybody thinking, like, wait a minute. So now a test can be done. You could take a sample of somebody's DNA, and you can analyze it, look at it, and you can figure out if they have something wrong with them. Think about that. That could be bad. That could be bad because if 2 people, for example, went in to try to get a job somewhere. And those 2 people are both qualified. They're great, they're wonderful, they're fighting for the job, they're perfect. The employer sits back and says, okay, here, I'm going to take a little sample from you and a little sample from you, and I'll be back in a couple of weeks. They could go and take that sample of DNA, analyze it, and figure out if you have any disorders. And I'll be honest, if you're an employer, you probably don't want an employee with any hidden disorders. A couple reasons. They may miss a lot of work. Number 2, they're going to be really expensive to insure with health insurance. They'll be costly. They'll be out of work. So that person can say, you know what? I don't really like the way your DNA looks like. I'm going with the other guy. That's wrong. That's discrimination. Okay? George W. Bush in 2008 actually made it against the law to discriminate against somebody based on what is in their genetic makeup. So just kind of interesting there. I mean, there's lots of laws out there that are protecting against discrimination for a variety of reasons. But this one's kind of been one of the last ones that's talked about. You can't discriminate against basically something in your genetic makeup that's hidden even. You can do a test and determine how prone you are to cancer. Okay, not many people get that done at this point, but you can. So it's kind of raises some ethical issues. So, but overall, the Human Genome Project is wonderful because now you have the locations of all these genes. If a gene is broken, they're pretty much now the research aimed at trying to fix broken genes. You get the idea. So that is it. That's the chapter. Are there any questions on this stuff?